Okay, so last one in the notes. This one's kind of a little different too, so I wanted to make sure we did this one. Okay, did an example like this before you started your assignment. So here we go. Amazon is one of the largest internet-based retailers in the world. The company offers a Prime membership for a fee, which provides certain benefits for members. A recent report states that 46% of households have a Prime membership. Penelope wants to know if this proportion is different from her hometown, her large hometown. She selects a random sample of 80 households from her hometown and finds that 43 of them have an account, a Prime account, a Prime membership. Okay? So she wants to know, is there convincing evidence that the proportion of households in this town differs from her claim? Okay? So she wants to see 46% of all US households. She's comparing that to her town. Is her town different than the national average? Significantly different. Okay. So, first thing, and then it says, is there convincing evidence to show it differs? Okay. So, um, first thing we're going to do is pull information out. So, out of that, what's important? What's important that we can pull? 46% would be P. Absolutely. What else? N equals 80. Good. What else? What else are we going to need later on down the road that would be important to note now? Exactly. It's going to be a proportions question. So it's going to be P equals true proportions. True proportion. Good. Good. P hat is 43 out of 80, which is roughly a little over half. Yeah, 50.538, 5375. Yeah, so what's our hypothesis going to be? Greater than or less than? Yeah, it's going to be differs, right? In the notes, I made a note of highlighting it, but again, it won't be highlighted when you guys see it on homework, tests, quizzes, but I did it in the notes just to show you what you look for. Okay. All right, good. We're ready to go. All right. So the P equals the true proportion. So 0.46. We know P equals 0.46, but that's the true proportion of what? Yeah, all US households that have Prime memberships. Okay. We talked about the hypothesis. Hypothesis always starts as the null is their claim, which is P, so 0.46, right? The alternative, we have three options: greater than, less than, or not equal, or just not plain not equal to. We said this one was going to be not equal to because of the wording differs. Differs means it could be greater, it could be less, just differs. Okay. Significance level doesn't say what significance level they want us to, so we'll go with the 5%. Okay. Conditions, assumptions, let's check those. So let's see, they took a sample of 80. It says a random sample, so stated. Random sample of 80. 10% condition, so we have to show that n is less than 10% of big N. Well, we know that little n is 80, because that's the sample size. Oops. Big N, we don't have a number, but what would we say in words for big N? There you go. All U.S. households with prime. Okay. Last one is normality. So N times P greater than or equal to 10, and N times 1 minus P greater than or equal to 10. Okay, so we know N is 80. We know P is 0.46. So it's going to be 30 something. What is it? 80 times 0.46. 36.8. Yep. That's bigger than 10. And then 80 times 0.54. 43.2. So our numbers are big enough. Test statistic. Test statistic I had already put there because that's the same one we'd be using. That's the one we use for a one sample z-test for proportions. Okay. Now the calculations. So we're going to draw a picture. So what was p hat? P hat was 0.538 minus 0.46, and then 0.46, 1 minus 0.46, n is 80. Okay. What's the center of our curve? 0.46. Always going to be P. Okay. So go to the calculator. Let's see. Before the calculator comes up, we need to shade. So our p hat is 0.538, which is greater than. This one is not greater than or less than. This one is differs from. So we're going to shade towards the extremes. We always shade towards the extremes. That's one half of it. How do I determine what the other half is going to be?
0.538 minus 0.46, the difference at the 0.46.
Exactly. Find the distance here, and then subtract it from 0.46. So the difference here, 0.538 minus 0.46, the difference here is 0.078. So subtract that from 0.46. And we get 0.382. We're also going to shade over there. Okay, so the two greens are exactly the same size. Stat tests down to number 5. 0.46, 77, let's see, not 77, it's supposed to be 43 out of 80. Not equal to? Again, you can go calculate or draw. It doesn't matter which one you do. Calculate gives you a little more data. Draw gives you a picture. That's the only difference. So we know that our z-score is going to be for 0.5 for p hat 0.538. Our z-score is 1.39. The other z-score would be negative 0.39, and then we know our p-value overall is going to be 0.1643. Okay, and then p hat and n we already knew. Okay. So again, the p-value the calculator gives us is always both. It's always both greens. If we want to find just one side of the green, you just take that and divide it by 2. Okay. So you've noticed the last two, we've had two-tailed tests, right? Two-tailed meaning not equal to. What's happened to the p-values? What have you noticed about the p-values versus the ones we did earlier in the chapter? They're larger. Yeah, that's the thing with differs. I think someone asked at the beginning, well, why can't we always do not equal to? Isn't that worst case scenario kind of thing? I'm like, yeah, you could, but it's going to be harder to reject at that point. It's harder to reject not equal to. We only do that when we have to. If we don't have to, we don't want to do not equal to. Okay. All right, here we go. So since p-value 0.1643 is greater than alpha level. So if p-value is bigger than alpha, which one? We fail to reject the null hypothesis. Okay. That takes care of 1 and 2. Now number 3. Therefore, we lack sufficient or significant evidence to show or to suggest that I get a lot of people saying, what happens is I get a lot of people putting this. That's not in context. That's symbols. So we have to put that in context. Okay? So what that says is the true proportion of households with prime accounts differs from 0.46. Okay? This town, we can't say there's not enough evidence to say that this town is that much different than the rest of the United States. We can't say that. The only way we could say that is if we could reject. We can't reject the claim. We cannot reject. We fail to reject. We lack sufficient evidence. So it's exactly the same. What was I going to say? Suggest that the true proportion. So the beginning question, the first question, we kind of skipped over. Did we answer this question? Did our conclusion successfully answer that question? If we did, we're good. We don't have to answer it. But so is there convincing evidence that the proportion of households differs from the claim in the report? Did we answer that in our conclusion? Okay, then we're good. We don't have to come back to it. You can if you want to put, it'd probably be good to say C conclusion, because that's where we answered it. Okay. Okay, so last question. Would your conclusion change if we completed the test at the significance level of 1%? So if we change the significance level to 1%, would it change our conclusion? No. No. Because use words, numbers, or drawing symbols to answer. We don't have to use all of them. We just have to use some of them. We had to use something. We can't just say no. Why would we say no? I agree. We would say no. We would still fail to reject. Why would we fail to reject? Exactly, because p-value would still be too large to reject the null hypothesis. Same thing for this guy. Same thing for 10%, right? So we can just use quotations to say it's the same thing. It would be the same thing. No, because the p-value would still be too large to reject the null hypothesis. What if I had an alpha level? You won't ever see this, but let's say I had an alpha level of 20%. Then it would be fine, right? Then it would be, the p-value would be fine. I've never seen an alpha level that high, but if it does happen, we would reject. Okay. That's another big question. That's another big question they like to ask. If I change the alpha level, would that change anything? The p-value, let's see what I got. 0.1643?
Do we have to divide that by 2?
No, unless they ask you to. The one the calculator gives us covers both. Now, if you were to do it using your tables, like if I were to use my tables, I would only get one at a time. So it would give me this guy over here, and then I would add it, I would double it. But so if you're using your calculator, you don't have to worry about adding both because it gives you both.
So then why do we divide it in the previous question?
Let's see.
Well, you were showing us why it was divided.
Let's see. Right here. Why did we divide it? So here's the p-value down here, right? I just divided it because it was the first problem we had done showing us a two-tailed. So I wanted to just break it up. It wasn't needed. It wasn't necessary. You can if you want. There's nothing wrong with it. Yeah, absolutely. If you want to break it up and say 0.1643 divided by 2 and say, oh, 0.08215. You can do that. They won't mark you off for that. It's just not necessary. Yeah. Here's another thing. If someone was doing a test and really wanted to reject, what's something shady they could do to be able to reject? Change the alpha level, right? That's why you need to set your alpha level before you do this, because I could easily reject. Oh, I'm going to change my alpha level to 20. Boom, reject. Reject your claim. You're wrong. That's a pretty low bar to cross. 20% is a pretty low bar to cross, but you could be shady and do that. So that's why it's important before you do any of these calculations. That's why significance level is done before calculations, because stuff like that can happen. Okay, so if you're doing it, that's why we always do that. Okay. All right. Okay, that's it. That's so the rest of the time, I'm going to get you guys start on your assignment. It's not due till next week, but I'll let you guys start on it. If you have any questions, um, that's what we're here for. So you can ask, and then you can also, the answers are all in the back of the book. So you can check at home.